All right, we got two videos coming at you here for section 4.6. Title of this section is Higher Order Derivatives, which is really a big word, or a big phrase, I guess, for multiple derivatives, I guess the best way to say it. So, meaning, when you see this phrase, all that means, and you can see it on the beginning of your note sheet, right, is that, yeah, we call y prime the first derivative, but then you can go y double prime, y triple prime, and so on and so forth. And that just means the second derivative, the third derivative, and so on and so forth, right? So my job here is to just give you, I'm going to give you two examples of how this works, and then I'm going to let you practice a couple. Then we'll have another video for the application part of this. So let's look at example 1, right, which says y equals 8x to the third minus 7x squared plus 10x plus 5, okay? And it says, and this is kind of new notation for us, so we have to get used to this. It says find, and then it kind of like throws this at you right here, right? So what that means is, kind of just make a note of this, and you can see it in the table above. It just means second derivative, right? So what does that mean for you? Well, what do we already know how to do? We already know how to do the first derivative, so what is that? So that would be 24x squared minus 14x plus 10, right? And then the second derivative, and this is kind of the new piece right here, right? To find the second derivative, all we do is we kind of pick up where we left off. So as soon as I write y double prime here, all that means is that we're treating the first derivative like a new function, and to get to the second derivative, we're going to derive the one that came before it. So if I derive 24x squared minus 14x plus 10, I get 48x minus 14. That's all they're looking for. All right, let's try that second example, right? So f of x equals e to the 5x plus 2, right? It says find the third derivative. So let's start with the first one. So this is one of those rules we talked about last week, the chain rule, right? So the first derivative is going to be e to the 5x plus 2, right? We rewrite that. Then we derive the exponent, so times 5, right? Okay, so second derivative. Well, remember this 5 now just acts as a constant. So I'm just going to keep the 5 here, right, and derive e to the 5x plus 2. So rewrite it again, times the derivative of the exponent, that's a 5. Okay, so let's simplify a little bit because we can obviously do 5 times 5. So that's 25, e to the 5x plus 2. So for our final step here, they want to do 3 derivatives, right? So we're going to pick up right where we left off here. So the third derivative, right, 25 just hangs out. And again, here we go with the derivative of e. So rewrite it, times 5. So how would I write my final answer here? 25 times 5 is 125, and then e to the 5x plus 2. So what you want to do now is, I have about a couple more examples in here. We'll do one more together, and then I want you to try the 4 we have after this third example. See if you get the hang of it. All right, the last example, right? So it says f of x equals ln of 4x minus 1. So let's start with the first derivative, right? ln rule says you got to do 1 over that quantity, so 1 over 4x minus 1 times 4, right? Okay, now second derivative. So now here's the thing, because we go back up here, this is kind of like 4 over 4x minus 1, so we kind of don't have a choice now. When we go to do the second derivative, we're going to have to do the quotient rule, unless you feel like bringing that 4x minus 1 up to the negative first power. But I'm going to do the quotient rule here. So low, right, d high, so that would be the derivative of 4, right, that's 0, minus high, right, so 4 times the derivative of low, right, d low, and that would be the derivative of 4x minus 1, that's just 4, all over low squared. So it looks hard, but actually this kind of cleans up real nice, right? This first term zeroes out, and so your final answer here looks like negative 16 over quantity 4x minus 1 squared. All right, so pause the video, try those next 4 problems, and then I'm going to flash the answers up on the next slide. And then, of course, if you have questions, we could talk about them in class. Okay, so again, if you have questions, we'll go over them, but here are the answers to those 4 practice problems. So practice problem number 1, your first derivative was 1 plus x to the negative second, and your second derivative was negative 2x to the negative third. Okay, practice problem number 2, first derivative was 24x times 3x squared minus 7 to the third. And now notice, before I write this second derivative down here, you're going to have to use the product rule to get to the second derivative, because you have 24x as one function and this cube thing is another. So the second derivative, this is pretty involved here, would be, remember it's commutative since it's product rule, so the order doesn't matter, but 24 times 3x squared minus 7 to the third plus 24x times, and then here was the derivative of that other piece, times 6x. All right, practice problem number 3. Sixth derivative here, so after about the third one, we just write the number. That actually is going to wind up being 0. And for the fourth practice problem, third derivative here winds up being 2x to the negative third.